So the derivative of ln x, as always, is 1 over x. The derivative of e to the x is e to the x. The derivative of ln u is 1 over u times u prime. And the derivative of e to the u is e to the u times u prime. Right? Boring. So the derivative of ln sine x is 1 over sine x times cos x. And the derivative of ln x squared plus 5 is? And then as we come down over here, the derivative of e to the tan x is? And the derivative of e to the 5x is e to the 5x times 5. So, review of chapter 3, right? So the antiderivative of, I don't like, this is correct, but I like to write it like this. But it's the thing. The antiderivative of dx over x, or 1 over x dx, is ln x plus c. The antiderivative of du over u is ln absolute value of u plus c. The antiderivative of e to the x plus c. And the antiderivative of e to the u is e to the u plus c. Can you see why we like e to the x? Its derivative and antiderivative are the same. It's fantastic. You're right, it is. Okay, flip the page. Bless you. So we're going to finish this page and then we're done, and I'm going to leave you alone to work on some stuff. I'm so softy. Okay, now try these. Take a 5 out. The antiderivative of e to the x is, and you're finished. Okay, number 24. Can you do that just by looking at it? No, Mr. Att. We have to do something first. We have to let u equal 5x. So du over dx is equal to 5. So du is equal to du over 5 is equal to dx, so our antiderivative becomes e to the u times du over 5. One-fifth antiderivative e to the u to u equals there you go. Okay, what are you going to let u equal here? Du over dx equals secant squared x dx. Oops, got ahead of myself. So the antiderivative, so you take out the tan x, you put u in, you take out secant squared x dx, and you put in du. This all comes out, this all comes out, this comes in. That comes out, that comes out. Like it's always going to be easier after the substitution. If it doesn't become easier after the substitution, you've screwed it up. If that ain't a good rule of thumb, I don't know what is, okay? At least for u substitution. There are going to be others eventually as we talk about different types of integration techniques. There are going to be others that are going to make it messier and messier and messier, but in some ways I'll use the word easier, but smaller. Anyways, the next one's a typo. There should be an X there, and there should be brackets around the e to the x. So we'll let u equal e to the x. Now you're thinking to yourself, which e to the x? The one inside the brackets, yeah. Du over dx equals e to the x. So du equals e to the x dx. Can you see how you can get a little bit confused with this one? So your antiderivative becomes cos u du, which becomes negative sine u. No, just sine u plus c, isn't it? The antiderivative of cos is negative sine. No, it's just sine. So sine e to the x. Okay, what about the next one then? This one right here. This rep I don't see a -1 anywhere, so I better deal with it. So this comes out, and this comes in. What? The derivative e to the negative x is e to the negative x times the derivative of negative x. And the derivative of negative x is -1. So that's where it comes from. So it becomes secant squared u times negative du. Take the negative out front. The antiderivative of secant squared is tan, so it's negative tan u plus c. And we're finished. One more, no more? Ready to rock the house? Give me a rock the house. Rock the house! Alright, there we go. What does u equal? There you go. So du over dx equals e to the 2x times 2. Mr. F, I don't see a 2 there. Well, that sucks. Du over 2 equals e to the 2x dx. So this comes out and gets replaced with a u. This comes out and gets replaced with a du over 2. So 1 over u cubed du over 2. Now that's not very nice looking, so let's take the 1/2 out front. Let's write it as u to the -3 du. Antiderivative of u to the -3 is? Add 1. Divide by the result. U to the -2 over -2 plus c. Make it look pretty, because that certainly isn't. -1 over 4. Yeah, that's a good call. Over. C. And that's it. Now, if you look ahead, and I'm going to record this, if you look ahead to integration day 4, have I opened this? Integration day 4. Zoom out. Zoom out. Page, whole page. The first page is just shortcuts, how to jump to the answer. Because we've done this so much now, you should be getting to the point where you can just look at it and go, the answer is. Okay, shortcuts, more shortcuts, and then we're going to do antiderivative of arctan and those ones. Those ones are a little bit, these ones are a little bit funky. Okay, so we've got some arctan to do. They're not so bad. And then we're jumping back to the substitution again and using arctan to do stuff. Some more arcsine, blah, 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 blah. So it's really not that bad. The first part of it is just jump into the answer. Okay? And then the last bit of it is arcsine and arctan again. So they're not so bad. Okay? And then if you look at integration day 5, holy computer, documents, courses, is that it? Integration day 5? And there's no more? What? Integration day 9. Day 4, day 5. No, day 6 is something else. Day 6 is chapter 5. So that takes us to the end of the chapter. I have one more thing to do with you on slope fields. Integration day 5. I gotta check my number. We've got 2 more things to do. We got day 4, we got day 5. Oh, sorry, integration day 5. I'm an idiot. There it is. I'm looking at it in the face. So, yeah, but that's chapter 5. That's chapter 5. So, integration day 5 is, if we look at it from the big picture, so it's just fast ways of doing things. These are all the formulas that you can use if you really want to memorize more things. I'm not a big memorizer, so I tend to not do that. But then we're going to talk about differential equations, so equations with derivatives in them. You have it. Implicit antiderivatives? No, you would cry in the corner. What? Implicit antiderivatives. No. Well, not really. So we'll talk about derivatives, solve equations that have in them. Chemistry, biology, use. And we have slope fields. So we have 152. We're going to have one thing to do. I've got it over there with us. Hopefully we'll be done by Friday, so that all we have to do after spring break is chapter 5 and 7. 5 is pretty fast, 7 is not. I would like to spend only a week in chapter 5, so we have 2 weeks for chapter 7, or more, maybe 2.5 weeks. And then you get two weeks to review for the exam. What? No, I don't want to. Okay, so if everybody wants to look at their assignment page, we have completed. This is the part where you go, OMG, I'm behind, or I'm not behind. We have completed 6.1, anti-differentiation. We've completed 6.1, anti-differentiation trig functions. We've completed 6.2, substitution. We've completed 6.2, trig functions. we've completed 6.2 logs and exponentials. And then tomorrow we're going to do 6.2 inverse trig. So we have 6.2 inverse trig to do tomorrow. And then we have differential equations to do in slope fields, and that takes us to the end of chapter 6. So you're looking at this going, Mr. App, we don't have anything for exponential and log functions. So what I was going to do while you guys were working on this was I was going to make 5 questions up for your homework on that. And I'll post it on the web. It'll be 6.2 exponential and log functions. Actually, I might do all of them. I'll try and do all of them right now so that you just can go and, you know, I'll just call it the 6.2 supplement. Okay? Okay. So look for it on the web. No, I don't want to. Oh, I'll just stop this and then